ever scrolled through the App Store and thought, how on earth did they build that? I mean, we use apps every day that feel, I don't know, almost magical, right? They're fast, they're responsive, and they just work, even with what? Like millions of people using them at the same time?
Yeah, it's true. Building apps at that scale where they don't just like crumble under the weight of all those users, that's a whole other ball game.
Totally. It's easy to think of an app as just this pretty interface,
Yeah.
what you see on your screen, but what's actually going on behind the scenes to make it like really scale.
That's where it gets really interesting.
Okay, I'm intrigued.
One of the documents you shared, Mobile Apps at Scale Challenges,
Yeah.
it had this quote that really stuck with me. It said, "Most engineers who have not built mobile apps assume the mobile app is a simple facade that requires less engineering effort to build and operate." But honestly, nothing could be further from the truth, especially when you're dealing with like millions of users all interacting with your app at the same time.
So it's not as simple as just like, designing a few screens and then boom, you have an app.
No, not even close. It's more like, imagine you're building a house, right? Versus a skyscraper.
Okay.
The house, that's like your average app. It's manageable. You can wrap your head around all the parts. But a skyscraper, to support all those floors, all those people, you need a completely different level of architecture and engineering.
Okay, that's a great analogy.
Yeah.
So we're not just laying bricks here, we're designing like a whole system that can handle, what, massive amounts of weight, metaphorically speaking, of course.
Exactly. And that's where we get into these concepts of like modular architecture and dependency injection.
Oh, yeah, those were definitely on the list of things to unpack today.
These are super essential for building apps that can actually scale to millions of users.
So let's dig in. First, can we just like define those terms? Modular architecture and dependency injection. Like, what do they actually mean? And how do they apply to, say, that app you use to order your coffee every morning?
Okay, so let's stick with that coffee ordering app as an example.
I like where this is going.
So with a modular architecture, instead of having one giant monstrous chunk of code, you break it down into smaller independent modules, kind of like,
Like Lego bricks.
yes, like Lego bricks, exactly. You might have a module for, say, the menu, a module for the payment processing, a module for order tracking.
So instead of this massive tangled code base, you have all these neat little modules,
Right.
each with its own like specific purpose.
Precisely. And this is actually where dependency injection comes in. So think about how those different modules would need to like talk to each other. For example, the payment module that needs information from the order module.
To know how much to charge, right?
Exactly.
Okay, so it's like each module needs to be able to pass notes to the others, but in a way that doesn't create like total chaos.
Exactly. And dependency injection is like, it's like setting up a system where these modules can request the information they need from each other, but in a standardized way.
Okay, I'm listening.
It ensures that each part of the app is getting what it needs when it needs it, but without creating, like you said, a tangled mess of dependencies.
So it's like the postal service of your code base.
Lax. Sure, yeah.
Each module sends a request, and this dependency injection system, it makes sure it gets delivered to the right place, to the right module.
That's a great way to put it. And this is, honestly, it's critical for large apps because it makes them so much easier to maintain, update, and scale.
Yeah, I can imagine.
Like, imagine trying to make a change to that coffee ordering app if it were all just a one giant blob of code.
Oh, that sounds like a nightmare.
It would be. It would be. You change one line of code, and who knows what other part of the app would just, like, explode.
Yeah, you'd be afraid to touch anything.
Exactly. But with a modular architecture, you can update or modify one module without really affecting the others, as long as you're careful.
No, it's like renovating one room in your house,
Yeah.
right? Like as long as you don't mess with the plumbing and electrical, you're not going to accidentally demolish the kitchen.
That's a great way to put it. It gives you that separation of concerns.
It makes sense breaking the app down into these modules, managing those dependencies. That's how you go from like a charming little coffee shop app to something that can handle, the morning rush of a whole city.
Exactly.
So you've got all these different teams working on their own modules, right? Kind of like back to the skyscraper analogy. You have specialized contractors building different parts of the building.
Yeah.
But how do you make sure it all comes together smoothly in the end?
That's where these things called dependency injection frameworks come in.
Yeah.
They basically provide the rules of the road for how those modules are going to interact.
So the framework acts as like the project manager,
Right.
making sure everyone is on the same page, using the same tools, all that.
Yeah, that's a good way to think about it. And you have different frameworks for different platforms. So for Android, there's a really popular one called Dagger 2. And for iOS, Uber actually developed their own framework called Needle, which they later open sourced so other companies can use it too.
Wow, so they built their own tools just to tackle this dependency injection challenge?
They did.
That says a lot about how important it is.
Oh, absolutely.
And these frameworks, they're not just like managing the dependencies, right?
Right.
They also make the code much more testable, don't they?
They do. Exactly. Because when you have that modular architecture with those well-defined dependencies, you can test each module in isolation.
So it's like being able to, I don't know, test the plumbing in that skyscraper
Yeah,
without having to worry about whether the elevators are working at the same time.
precisely.
Love it. So you can be sure that each module is functioning correctly on its own.
Yeah.
Before you even start, integrating it into the larger app.
Exactly. Exactly.
And this is where automated testing comes in, right?
Yes. Yes.
Okay, I was hoping we'd get to testing today, because even with the best architecture in the world, things can still go wrong, can't they?
Oh, absolutely. Software is complex, and bugs, those pesky little things,
Yeah.
they're just inevitable.
So how does automated testing actually work in this, modular context? Are we talking about, like, robots typing on phones?
Laughs. Not quite robots, but I like the way you think.
Okay, good.
So basically, you write code that simulates user interactions, like tapping buttons, scrolling, entering information, and then you run that code thousands of times
Wow.
across all different kinds of devices, network conditions. You really want to put it through the ringer to make sure everything behaves as expected no matter what.
So it's like having this digital army of testers
Yes.
working tirelessly to find any, like, weaknesses in the app's defenses.
Exactly. And there are different levels of automated testing too.
Okay, tell me more.
So you have unit tests, right? Those check the smallest units of code, like individual function.
Like the atoms of the code base.
Exactly. And then you have integration tests. Those make sure that different modules are all playing nicely together.
Ah, so they're not just siloed off, they're actually talking to each other properly.
Right. And then finally you have UI tests, and those test the user interface, making sure the app looks and feels right.
So it's this multi-layered approach, testing everything from, like, the smallest cogs in the machine to the overall user experience.
Exactly. And for large-scale apps, this is absolutely essential because you can't manually test every single possible scenario. It's just not feasible.
Right, imagine trying to do that with, like, our coffee ordering app from before.
Exactly.
Every drink combination, every customization, payment method.
Oh, it would be a nightmare.
It'd be impossible.
It would be a logistical nightmare, and no one has time for that.
Automated testing to the rescue.
Exactly. It helps you catch those bugs early on, which speeds up the development process, and ultimately, it means a higher quality app for the user, which is what we all want.
Speaking of users, I imagine with millions of people using an app, there's some pretty unique challenges that pop up, right?
Yeah, you're right. And that actually brings us to another biggie,
Yeah.
state management.
State management. Okay, that sounds, I don't know, intriguing, but also a bit like something I'd use to organize my sock drawer.
Laughs. Well, it's definitely more complex than that.
Okay, good.
But the idea is kind of similar, actually.
Okay, I'm listening.
So imagine you're using that coffee app again.
Okay, back to the coffee.
You've added a few things to your cart, right?
Yeah.
But then you switch over to check your email, you answer a text, maybe you watch a quick video.
Multitasking, as any good mobile user does.
Exactly. But then you switch back to the coffee app, and what happens? Those drinks are still in your cart, right?
Yeah, thankfully. I'd be pretty annoyed if I had to start all over.
Exactly. And that, my friend, is state management in action.
Okay, so it's like the app remembers where I left off.
Yes, it's the app's ability to keep track of all that information, your order, your profile, maybe even your location, and it keeps it all consistent, even when you're jumping between different parts of the app or even using other apps entirely.
Wow, I never really thought about it like that. It's like
Yeah.
the app has this little notepad, and it's just diligently jotting down my every move.
In a way, yeah. And this becomes even more critical at scale because you have millions of users, each with their own state, all interacting at the same time.
So the app's juggling, what, millions of these little notepads?
Pretty much. And if it's not done carefully, you run into all sorts of problems. Inconsistent data, app crashes, the whole 9 yards.
Right, because no one wants to be that person, the one who brings down the whole coffee app. just because their latte order got scrambled.
Exactly. So developers put a ton of work into building these like super robust state management systems.
It's like air traffic control for apps, making sure everything lands smoothly.
Lashings. I like that. Air traffic control for apps. That's a good one.
So we've covered a lot of ground today. Modular architecture, dependency injection, automated testing, state management. It's a lot.
It is.
But these really do seem like, the essential ingredients for building the apps we use every single day without even really thinking about them.
They really are. And, we might not see all that complexity under the hood, but there are countless talented engineers out there making these seamless experiences possible.
Absolutely. To all the engineers out there building our digital world, thank you.
Hear, hear.
So next time you're scrolling through your phone, just take a moment to appreciate all those modular building blocks, those carefully managed dependencies, those lines of code, all working away to bring you your daily dose of digital delight.
I'll drink to that.
And that's all the time we have for today's deep dive into the world of building mobile apps that don't buckle under pressure. Until next time, keep exploring, keep questioning, and keep those app updates coming. This has been the Deep Dive.